in Midtown on a Wednesday night or what, everybody? Can I get a little enthusiasm? Let's go. My name is Chuck Danielsson, and I have come here today to warn you that there are pandas on the loose. Before we get that, let me tell you about my employer. I work for a company called Adaptive. We partner with capital and commodity market participants that value differentiation through technology. Big numbers I want you to look at here are 10 years, 100+ solutions. On those solutions, these are correct, not a compromise. They are what you want. They get to market quickly via accelerators like OpenFin and ones that we grow in-house. And in the end, what is done is yours. We deliver to you. Now, on to the pandas. What are these pandas? Well, I did hear a conversation earlier about data. And unfortunately, those are the pandas we're talking about, not our happy little pals here. Although I don't think these guys are going to be on a loose anytime soon. The pandas we're talking about tonight are the Pandas Data Science Library. So this is a cornerstone of Python data science, the Pandas library. You may have seen it in other forms. Maybe you've heard Conda, Miniconda, Anaconda, etc. These are combinations of packages that all leverage pandas. It is an incredibly popular choice for quantitative research, really across disciplines, right? This is some of the power of open source. If you want to go pick up an out-of-the-box solution that is provided by some enterprise vendor, you can't just go look at the docs, right? And really the thing that most of the data scientists in the room here will relate to is the data frame. It is tabular data's best friend. This is how we pass around data among pandas and really among this data science suite. And frankly, if you haven't heard of either of these, maybe you've seen Jupyter Notebooks. This is the most common home for Python pandas, in my opinion. It's a wonderful tool. The task at hand really is to define a problem, document the process for transposing that data, and then get the solution, right? And Jupyter Notebooks kind of serves as a combination of documentation and solution in one, right? So this is pandas. But I thought that they were on the loose, right? What does that even mean? So let's start with a proposed workflow. We're going notebook to solution. Your quantitative desk is over here. They spend all day in Python working in their Jupyter Notebooks. They take the results of these notebooks. Now I have to do something with them. What you do with that is up to you. But I could do a number of things. Maybe it's pretty quick, so I just put this behind some kind of lambda. Maybe it's actually synchronous, so I can request I wait for Python to finish. Maybe it's async. Sooner or later, you get to some massive data sets, the type of stuff that takes a machine 2 days to run. So I slice that up. I do some bigger batch processing, right? Or maybe I just take that output file and give it to you as a CSV because this stuff's urgent. Regardless, your options are there. Next is the API. So I've done something to take this problem and documentation, turn it into actionable code. Now I need to serve it to you via an API. And finally, via the client, wherever I access my microservices architecture, I get my data. But let's boil this down. What are we really looking at here? Step 1, notebook. Step 2, refine. Whatever you're doing to take that problem statement from the notebook definition, you need to refine this into a process. Next, you need to serve that, right? However I want to do it. If it's on that Lambda, whatever. And now we have what used to be just the visualization layer, the client, right? In this paradigm, our pandas are locked into this phase, okay? They are part of our native file system. They need native resources to do their things. In that world, when I make it down to V8, to the JavaScript world, I'm helpless with this code. But things have changed. As we Fin.js veterans all know, many things have changed, and this once visualization-only layer now has many new things. WebAssembly, spoiler alert, we'll come back to that one. Worker threads. I'm up here telling you I'm going to run Python somewhere else. I better not be blocking your renderer, right? Interop. We can't even count how many times that word's come up tonight, right? But that's the world the desktop's going into. And another tool I use in this one here called IndexedDB. This is a large quantity storage layer available to you in the browser. Depending on your systems, this could be 10 gigs, right? But here's who let the pandas out of the cage. They're in a good place. It's not a cage. It's WebAssembly. And everything we do here is built off, in this presentation rather, of a tool called Pyodide. Now let's roll it back just 2 seconds when I told you how cool Python was and how many people use pandas. That's why this is here, right? The ubiquity of a tool will bring it to new homes. JavaScript is a testament to that times 10, right? Pyodide itself is just a port of CPython for the pedantic in a room, which is just Python, to WebAssembly. Out of the box, what do I get when I just put that script tag in there? I get bundled libraries. So this isn't just a Python interpreter. No one's expecting you to only use those things. Much in the spirit of Anaconda, Miniconda, and all those data science libraries, I get the top 75 packages out of the box, NumPy, all the good stuff. Next, I get a JavaScript interface, import.js, and that's the DOM, window, as we know it. Whatever you need off of that. Now, the specifics to interacting with that are a little more nuanced, but not really. What else is supported then? What we're doing here is I'm running Python as a string. I'm taking your Python code, putting a little tick above and a tick below, and it's a string. And it's got to be a good string, right? This is white space sensitive code. But that's all I'm doing. Now, that doesn't mean you can't build large, complex scripts and use modules to bundle these things together, but you'd have to bundle that in on your own. So let's put this all together. I've got these pandas, they're on the loose, something with like a desktop, interop, etc. Let's start with the application architecture, and then I'll jump right into a demo and we'll see it in action. So, PandasUnleashead.app. We know what we want in the end. We want our awkward, happy face talking to the client. Great, so let's work backwards. Well, what is our client really? I know it's not just going to be React. I need something else, because I'm going to be talking to WebAssembly. I'm going to be offloading a large quantity of work, so I want to use a web worker. The web worker gives my React code a dedicated thread to do anything expensive. Now, these also need some things, right? My React code needs the Python, and my web worker, in this case, just talks to IndexedDB. What we've done for this specific application is actually, in a separate application, have it's a pretty popular model you might have seen with something like a CouchDB, et cetera, where we synchronize a local database with a backend service. Should I lose that connectivity, I still have access to my data. I can still run all of my Python scripts in the browser. And then a nice little automated script. All you got to do is take some Python, string above, below, and now I have my Python as a JavaScript string. So let's take a look. We'll start here in the browser after I brag about my email count. And refresh. So what we're looking at here is just a React material UI, etc. Up top, I've got a select. I'm going to go ahead and pick a couple of tickers from my portfolio. All these portfolio tickers are being read from my IndexedDB locally. I send that batch of portfolio identifiers. In the FTC3 world, this is an instrument list. I send an FTC3 instrument list over to my worker, and my worker says, oh, okay, I'll go talk to the database, and then I'll tell it to use this Python and get a result. And then I pull this up here. Hot dog. So now, let's do the whole thing. We want to compose this into one desktop where I can share these contexts and rely on the fact that all my data is cached locally. Gavin was kind enough to introduce us to OpenFin Workspaces, and one of the awesome features was this is the amount of code it took me to put all these little widgets on OpenFin Workspaces. That's 3 lines for those of you who missed that one. And I'll open up here and we can see my various collection of little widgets. I'll launch my first one here, which is our, this one's going to take whatever that little portfolio we put in and compare it against the S&P 500, sure. I'll select a color channel. Let's get on a color channel. There we go. So I'm on the orange channel. I actually had a little cached data set in there, so we'll pop one more up. And then let's go ahead and submit. Same thing. But now, I'm not in the browser anymore. Right? If we take this back to this, if I want to compare these two, I'm navigating from tab to tab. From here, I want to effortlessly be able to combine these things into one piece and not have to worry about toggling from screen to screen every time something changes. So I'm going to go ahead and grab my one matrix, put it in the bottom, take my second matrix here, put it in the top, and now I've got a composed page. Last piece, I'm going to join my orange channel. Right away, as I join the orange context channel, it knows what the cache value is. And let's just do the bottom one. This is a bit of a race. Usually one of the matrices wins here. but we'll see. There we go. Yep. And there we go. So what are we looking at? We're looking at no network requests. We're looking at 3 Python files in 1 database. If you spun up 5 more of these things, I could just drag and drop them in. The context is cached. Well, I'm sorry I caused so much alarm about the quantity of pandas. I do need to mention one thing. At Adaptive, we are hiring. If I didn't say that, our recruiter wouldn't give me back the house keys, so thank you for getting me home. Thanks, everybody.